Hi kids, welcome to a new unit. Today we are going to talk about relationships. Sounds kind of personal, right? Um, a lot of this lesson is a play on words. We're going to talk about relationships and if they're functional or not. And we can make a lot of jokes about that. But seriously, there is such a thing as a mathematical relationship, and some mathematical relationships are functional and some are not. So this is Objective 56. We skipped a big chunk and we will come back to it. So don't you worry, we're not going to forget those. So, newsflash, I don't need to tell you this, that not every relationship is functional. In math or in life, right? And that's how life goes, right? And so, just in real life, mathematical relationships can either be functional. I don't know if you can tell who this classic family is. I can show you my picture. Looks a little bit better in color. Who's that? Extra credit if you know that's the Brady Bunch. How about these guys? Do you know them? I think that's Malcolm in the Middle. That's an old one. Anyway, that didn't print too well for you. So anyway, so a relationship in math, though, it can be any pair of numbers. It can be completely random or it can be generated mathematically, but it's any two numbers that go together. And so a relationship of numbers can be in lots of different forms. So I have an example here for you. And this is not a random assortment of numbers. This relationship of numbers has to do with the total cost of a pizza. So maybe when it was snowing the other day, your family didn't want to go out and you ordered a pizza in. That'd be nice. We just had mac and cheese, so no pizza for us. But anyway, what if we use this equation? We could say y equals 2x plus 6, or verbally, the total cost, that'd be the y, is 2 times the number of toppings. So say you got 3 toppings, 2 times 3 is 6, plus the base cost of the pizza, so $6. And if you got it delivered, you need to tip them too, right? You could use a table for this. So as a 0-topping pizza, that sounds terrible. I don't know what kind of pizza you're eating. Maybe it's just, you like saucy bread. I don't know. That'd be $6. A 1-topping pizza, so just a cheese pizza, would be $8. A 2-topping pizza, 10. 3-topping pizza, 12. 4-topping, and so on. And so this is an example of a table. And we can get coordinates from this table. So see how this is the x and this is the y. So I could have coordinates 1, 8 and 4, 14 if you remember how to graph. That'd be great if you remember how to graph. But if you don't, here's a little bit of a refresher. So here's the 1, 8. So here's the x, 1 over 8 up. See, we have this 3, 12. So 3 to the right, 12 up. So that's what this means graphically. So all of these things communicate the same thing. It's the cost of pizza per toppings. And yeah, so those are examples of a relationship. X and Y have a few different names. One pair of names that might be relevant as we go on is that X is sometimes called the input, and the y is the output. So for example, in this equation, I can input the number of toppings, so say 3 toppings, to get the output of the cost, $12. That's just something to have on your radar as we go through. We'll have a lesson that details that more later. Oh, pause. Okay, well, I was going to pause the thing while I flip pages, but I guess I got butterfingers and that's not working so hot for me. So let me flip the page. You guys can take a little 5-second mental break, and here we go. So, all right, so like we said, relationships can be generated by something like the cost of a pizza, but it can also be something that's kind of random, something that's unrelated. So, for example, This is mileage that I ran in December and the temperature that it was outside. Now, you could make the point that a colder temperature would discourage me from running. However, the temperature doesn't really affect the number of miles that I ran. So if I woke up and the temperature was, I don't know, 17 degrees, I would not have the thought, oh, well, today I must run 2.42 miles. Like that's just not a thing. So this is kind of more randomly generated. It's just listing data. So my X value is the miles that I ran, and this just happens to be a temperature. Now, a functional relationship is different than a not functional relationship in that every X has its own Y. Pardon me, guys, sorry. And this is where we kind of joke about people relationships, right? Every X has its own Y. Like, that's a functional relationship, right? So that means I have 2.76 and it's with 32. 3.25 and it's with 27. 3.4 and that's with 22. Oh, 2.76 came up again, but it is still with 32, so that's okay. We still have a functional relationship. We have a not functional relationship here. Still have the same data here, same here, same here. But this time, 2.76 shows up with 25 degrees. What? 2.76 went with 32 degrees and with 25 degrees. Now these are still a relationship, but it's not functional. So in this case, an X has two or more different Y's. I know that sounds kind of weird. I'll show you what that looks like graphically in just a second. But I'm going to make it even more confusing. So sorry about that. Now, while every X has its own Y, and this is not functional, every Y can have multiple X's. What? Seems a little unfair, right? So in this case, the 22 is repeated, but it's okay that it went with 3.4 and 3.61. What matters is that every X has its own Y. So all of these are different. So I don't see any repeats here. So I don't see any of these X's showing up with a different Y. So this is an example of a function. Yeah. This is kind of confusing. So I really recommend that you keep these notes on hand while you're learning this stuff. Eventually it'll set in with enough practice, but at first it gets, it's a little bit shaky. So you can determine if a relationship is functional or not by using a pencil test. And this is really handy if you already have these relationships in graphic form. You can always graph them for yourself if you want. But yeah, we call this the pencil test. And it doesn't have to be a pencil. Typically we call it a pencil test because when you're doing your math homework, you have a pencil or a pen in your hand. But basically, you can tell that a relationship is a function if you can move a pencil across the graph vertically, not horizontally. So pencil test doesn't go like this, but vertically and only intersect one point at a time. So if I go like this, like right here, sure, that's a function there, but then you go here, nope. I'm crossing here and here at the same time. So this is not a function, not a function. Here, 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. We're just going to imagine this little bit here is an up and... I think it's still a gradual slope, so we'll just kind of alter it. See, if it were like this would be a function. Here, what do you think? Function, 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 function. What about this part? Nope. This is not a function. So you can use the pencil test to determine if a function, if a relationship is a function or not. So let's go to the back here and do a little practice because this is, it's kind of confusing. So I wish I were here at school with you guys because I have kind of a fun little game using some dice, some X and Y, and that X goes with this column and the Y goes with this column. So I'm going to roll some dice and generate some numbers randomly, right? And I'd like for you to tell me if this relationship is functional or not. So let's start with our numbers. So here I have 2 and 1. Well, so far, every x has its own y, right? All right, so that's functional. All right, and now we have 5 and 6. So far, so good. Every x has its own y. And now I have 2 and 4. Is this still functional? Nope, it is not. At this point, it becomes not functional. 2's with 1, 2's with 4, and that's not okay. Okay, you're going to get the hang of this the more you practice. Let's keep going. Okay, here we have 6 and 2. Obviously, that's just the first one, so we're still functional. Here we have 3 and 2. Suspicious. What do you think? Functional or not? Remember, every x has its own y, but y's can have multiple x's, right? So as long as 6 is with 2, 3 is with 2, and 3 is only with 2, 6's are only with 2's, that's still functional. It'll make sense if we keep going here. How about 4 and 5? Still functional? Yep, sure is. 1 and 3. We got 3 here, 3 here. Are we still functional? Because if I cover this up, I don't have any repeats of the x's, do I? So I'm functional. It doesn't matter what the y is. I don't have any repeats. So pretty soon here we're going to get something. Oh, there we go. I have 4 and 6. Okay, is this functional? No, it's not. 4 is with 5 and 4 is with 6. 4 can be with 5 or with 6, but not with both. So at this point, it becomes no longer functional. All right, let's try one more. Okay, 2 and 3. Good. Okay, how about this? We have 4 and 4. Is it okay to have the same number on both sides? Yes, it is. How about 2 and 3? That's weird. Weird. Is that okay? 2 and 3, yes, that's fine as long as 2 is always with 3, right? That's okay. 6 and 5. 1 and 3. Uh-oh. 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 We have a repeat. Is it still functional? Remember, every x has its own y, but y's can have multiple x's. So if I cover this up, I only have repeats of 2, and those are okay because they're both with 3. Oh, we have 2 and 5. Dun, dun, dun. What's our trouble here? Yeah, 2 is with 3, 2 is with 3, but now 2 is with 5. Not okay. There's where it becomes not functional. All right, so in April, you're going to get some part questions, and they might look like this. They might look different too, but we like to get you acclimated to these so that they're not completely unknown when we get to that point. So this says, points are shown on the coordinate plane, just one form that you can see a relationship of numbers. The points represent a relation where x is the input and y is the output. So there's that input-output vocabulary that I told you about. So it says, to complete the sentence, to explain whether or not this set of points represents a function. And on the computer, you would drag and drop each appropriate phrase into each box, but we're just going to draw some lame arrows. Sorry, can't drag and drop on your paper. Take a second to think about it. All right, first of all, would this pass a pencil test? Yeah, absolutely. If I cross a vertical line across here, it's only going to intersect one point at a time. So that's just one way that you can prove that this is going to be a function. This is a relationship of numbers, and it also represents a function. So it does represent a function. But why? Each input has only one output. Each output has only one input. One input has two outputs. One output has two inputs. Wow, that's confusing. Let's replace input with x. X, input is x. Input is x, input. And output is y. Turn that into a y. Okay. Each x has only one y. That sounds familiar. Each y has only one x. No, that's not true. A y can have multiple x's. One x has two y's. That's not okay. One y has two, and that might be the case, but that's not going to prove that it's functional. So which one must it be? Yeah, that's the definition of a function. Each input has only one output, or each x has only one y. Cool. All right. So again, keep these notes nearby. Those will help you with your homework. And now I'm sure, I'm so sorry. Don't mean to be hacking in your ear. Hopefully this homework is on its way out to you. I can walk you through a couple of them, just in case you are thoroughly confused. So get your name at the top, class period, and the directions say to determine if the following relationships are functional, which you can mark with an F, or not, which you can mark with an NF. If the relationship is not functional, indicate or circle Y. So please note that if it is not functional, you have to do this part too. So don't forget that. And so I don't rob you of some of your homework questions, of your practice opportunities. Let's do some samples from the redo side. Haha. Okay. So let's look at, let's go down this right-hand column. So these take the form of coordinates, right? And a coordinate is made up of the x value and the y value. So this right here would mean the same thing as a table, written like this. 9, 2, 5, 1, 0, 6, 3, 4. That means the same thing. X and Y, X and Y, X and Y, X and Y. You don't have to write all this. I'm just trying to make a point, right? Okay, so if I'm looking along here at the first part of every coordinate, or if I'm looking down here, is this a function? Yeah, every x has its own y. In fact, there aren't any repeats in the x, so you don't even need to look at the y. We know that every x is going to be unique. So therefore, this is going to be a functional relationship. Okay, let's look at the next one. Take a second and see if you think that's going to be functional or not. Do you see what I see? Here and here. Okay, now this would be fine if 7 is with the same y value. But 7's with 3, 7's with 6. Dun dun dun. This is not functional. Okay. And so therefore, I have to circle y. So the reason why this isn't functional isn't because of the 7. The 7 can repeat, and that's fine as long as it's with the same number. But the reason why this is not functional is because of the 3 and the 6. Those must be the same if they're both with 7. Cool. Let's try another one. Let's go to, why not the middle one? So if I look down here, all the x's are different. So what do I know must be true? Yeah, this is functional. I have no repeats. But let's say we look at, this one here. We have repeats here. Uh-oh. So let's investigate. If -2 is going to come up twice, it has to be with the same number. Or if 1's going to come up twice, it's got to be with the same number. But it is not. And not again. So this is not functional. You could say even either here or here would be the reason why it's not functional. Remember, y's can have multiple x's, like this and like this, but not x's. All right, here comes some pencil testing. Functional, not functional? Not functional. How about this one? That is functional. How about this one? Ooh, there's not a line connecting those. If I cross my pen across here, does it only intersect one point at a time? Are you looking carefully? Rose. What do you think? It is not functional because of these guys. Okay. So let's flip this over. This is your homework due tomorrow. Think it should go pretty quick. So you can get started on that. If you finish early, I do require you to find some math to work on until the end of class. Good luck, and I'll look forward to seeing you guys tomorrow. If you get stuck or need help, please don't hesitate to email me or see me at 8 o'clock tomorrow morning. I will be here waiting to see you. All right, see ya.